That's where we stopped last week. Finish creating this function. So last week I explained how the position driver code works. And then we created the sensor drive code. The sensor drive is to move my robot sideways to the right side. So checking the right sensor. And then stop according to a distance, a specific distance that I can set here when I call the function. Okay. So here my robot would move to the right until the distance to the wall or any object is 15. Today we're going to see how can I do the same for left and front using the same function, and then also create later the line follower. So first of all, let me change my camera. Okay, so that's the robot I'm using. Is a different robot than I used last week. That's why the first thing I'm gonna do is to change the pins. So every time I open the code to a new robot, and you should check what are the pins of this robot. Okay. Start button, the rest is missing. Okay, so I want to add left sensor and front sensor to this code. So the first thing is to allow my hardware to have these resources. Now I have get right, get left. For this robot, the sharp sensor is in the front. I don't know if you can see the camera, but in the front of the robot is the sharp, and on the side is the ultrasonic. So actually, right and left would be the ultrasonic and not the sharp. So what I'm gonna do, I'm gonna make the sharp sensor code as the front sensor because this robot has a sharp front, not ultrasonic. So now my front sensor is the one that uses the right sharp. So every time I want to check the front, actually it's going to check the sharp in front. Because I created a new function to this class, a new method to this class, I need to add it here. So now I have get front distance. Okay. And my left and my right they are not anymore the sharp sensor. Now they're gonna be the ultrasonic. And for ultrasonic, if we come to the Studica website, you see that for ultrasonic code, C++, I need to import the library. So import the ultrasonic library. I need to create a ultrasonic object that I'm gonna do it here. Okay. This object from the class ultrasonic has an input trigger and an input vector, which are the pins that we have. So we're going to have a ultrasonic right, and in my case, ultrasonic right is connected to the pins 0 and 1, while the ultrasonic left is connected to the pins 2 and 3. Okay, so now I have two objects for ultrasonic that I can use in my code. So okay, I come to the website here, and then I have this function. I already have the function there. Then it gives me two options. I can either return the distance in inches or in millimeters. So I will come here, get right distance. I'm gonna have guy, and get left distance. I'm gonna have this guy. For right, that's the object for right, and for left, I'm gonna use the object for left. So now, whenever I call these functions for these robots that I'm using here, it's going to use the ultrasonics for side sensors and the infrared for front sensor. Because it returns to me the distance in millimeters, I'm going to divide it by 10. So it will convert it to centimeters. Okay, I'm going to do the same for this guy here. So when I call this function, it's going to return what the ultrasonic is measuring in centimeters. Okay. So now I implemented the ultrasonic. I'm just telling the students to do not screen. Okay, so now I have the ultrasonic and the sharp implemented in my code. Whenever I call this function, it's going to use these sensors. So here, the sensor drive, what I want to do now, I want to implement for left, right, and front. So I need to defer these 3 ways. I could create one for each. So for example, I could have a sensor drive right, sensor drive left, sensor drive front. It's an option. It's an easy way to implement, but I prefer to put them all together. So what am I going to do? I'm going to create a new parameter here. It's going to be my direction. So string direction. Let me see if I have string in the movement. Oh, probably. If we don't, if it doesn't have, we're gonna see the error here, and then we add the string. So I'm gonna do if my user enter front. So that's one way using the string to check what was entered. Okay, so it means that later, when I call this function sensor drive here in robot.cpp, I'm gonna put 15 and I also inform which direction, front, left, or right. Okay, so direction in this case will be front. This function here will check if what's inside direction is front. The output of this function here is 0. So what I'm checking is this guy 0? If yes, it means that direction is front. Okay, I'm gonna do the same for left. The same for right. So here I'm gonna have left. Left. I'm gonna have a right. Okay, so according to what I'm saying user, but you, according to what I put here later, left, right, front, it's gonna select one of these if statements. What I have inside each if statement, what changes from when I want to front, when I want to left, when I want to right. What's gonna change is the sensor I'm using. So the first thing here is when I use front, I no longer we use get right, we use get front. Who's get front? The one that we just created here. Get front is here for the sharp sensor. In my case, I have a sharp sensor in front. Then I need to check what's the robot using. Okay, and then I'm gonna do the same for left, the same for right. And then left uses get left. And the right uses get right. Okay. So now according to what I want, front, left, right, I'm going to check a different sensor. Something else that changes is this logic here. So before we were doing only for the right side, if the sensor is bigger than what I asked, I'm going to move forward. If it's less, I'm going to move backward. But now, because I also have left and right, I no longer want to only go forward and backward. I want to also move sideways and forward and back. So when it's forward, this logic here will be a little bit different. And this forward, When it's forward, my robot. Let's see. When it's forward, my robot will move in X. When I'm talking about the sideways, for example, to the left, I'm talking about here, Y. And then for the right, it's gonna be the opposite. So here is gonna be minus 20. Right. Any questions so far?
No, it is good.
Okay, okay. So basically what I'm doing, let's review here. I call the function, for example, 15 left. It's gonna run this function. So this is 15, direction is left. I check the while. Is sensor reading within the range? Is the sensor reading close to 15? No, because the beginning didn't read, so sensor reading is 0. Then I come here. Is direction front? No. Is direction left? Yes. Okay, so I'm gonna run whatever is here, and I'm not gonna run right or front. I'm gonna read the sensor, the left sensor. Okay? Here's front, here's right, but in this case now is the left one. So I say the left sensor here, the left sensor being the ultrasonic, is ultrasonic being connected to the pin 0, 1. The sensor saving this information here is very easy. I check, is sensor greater than 15? If yes, so it means that my robot is far from the wall. I'm gonna move 20 in Y. Okay? 20 in Y is the left side of my robot, so going to the left. While minus 20 is the right side of my robot, going to the right. So if it's bigger, so if I have a wall, if I have this wall here, and my robot's far from this wall, I'm gonna move 20 positive in Y. 20 positive is the left of my robot. That goes like this. Otherwise, if I'm too close to the wall, if I'm less than 15, I'm gonna move to the right, minus 20. And then for the right side, it's the opposite. If I'm far, I move to the right. If I'm close, I move to the left. Okay? And that's it. So now I have a sensor drive that can make my robot go left, go front, and go right. Okay, I don't need to change anything else in the rest of the code. Let me build here. Just check if we didn't forget anything. Okay, so it's bottom here. Let's check it. No declarations match. So we changed, because we changed the header of the function here, I need to update it, the header file. So before I had sensor driver only with double dist. Now I have a sensor driver with double dist and also string direction. Okay, let me see what else. So we keep maneuver, expecting, semicolon, movement.cpp. So I go to movement.cpp, line 198. Okay, I have this tree here. Nice viewed. When you build, you're not sending the code to the robot. You're just checking if the code is right or not. So for example, I don't have any error, syntax error in my code. So I'm gonna deploy to my robot. So I set the position, then my robot moves to the left. I'm gonna put my robot more far, and then I'm gonna deploy. Oh, sorry, I don't have a battery to this. Let me take, just take a battery and come back. Okay. By mistake, I connect to my student robot, and then I make my student robot move. So let me connect to the right robot again. And then I can deploy the codes, the right codes. Okay. It's moving to the wrong direction. Let's see why. It's going left. Let me see if I put the right sensor here. It's 1, right here. Right. Make the left. I tested for right. Right here. I was testing before right, maybe the left sensor is not connected. So flip. There you go. Eight 15, I think this is too small. So I'm gonna put a bigger number. Let's put like 20. Right. Right here, right there. Okay, I think they're ready to go. One more. See almost. Okay. Oh. I have a connection issue with the robot. I try to disconnect and connect again to the robot. Yeah, so this is ultrasonic for some reason. Try to see why my ultrasonic doesn't work. Open the shuffleboard and can print to see what's going on. Okay. Let me see if I have the dress on. Don't have the dress on here. So I'm gonna debug here. So I don't know what's going on. I'm gonna print the ultrasonic on the shuffleboard. See what is it getting. Okay, since we're reading 25, so it need to read well. Official user. Says reading 11. So it seems to be working ultrasonic, but for some reason doesn't update. What? Action. So it's reading one time only. Okay. The ultrasonic has one more function. It doesn't say in the Studica website. But when you use ultrasonic, it's better use this one guy here because it makes sure that the ultrasonic is gonna update. If you don't put this guy, sometimes you have some conflicts that it doesn't update. When you do ping, for sure it's gonna ping. Otherwise, you're up to the hardware itself. Here, through the software, I'm controlling when I want the ultrasonic to ping. Let's see. That's the only issue. Okay, yes. Okay, so this one was the issue. The Studica website doesn't mention this guy. So if you take a look here, it never says anything about the ping. But we need this guy here. Okay, ping means that you're gonna say to your code, to your robot, that you're ready to start a new measurement with the sensor. Okay. I put in my other code, but I forgot to put in this one. Okay, so now I'm sure. I don't know if you realized before, but what was happening is that it measured one time the ultrasonic and did an update. So my robot stuck with that first measurement. Now that I have the ping function here, it will remain updating, 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 updating. Okay, so if I put, let's back to 15 here. Put my robot 4. Okay, it goes. When it reaches 15, it stops going sideways. I'm trying front now with the infrared. So I rotate my robot's facing the wall. Also 15. It goes and stops at 15. And then I'm gonna try left, rotate my robot to the left here. Show that the sensor is working. And my robot goes to the left and stop once it reaches 50. Okay, now I have the sensor driver that can go to any direction. This robot has an issue in the balance of the weight of the robot. The weight on the back is different on the weight in front. In front, the weight is much higher than on the back, so the back rotates more. This code here I made as simple as possible. It means that I don't have a PID control. You just apply a speed to the wheels, and then inshallah your robot's gonna behave the way you want. If you want to improve, you should add here feedback to control better the speeds. So we would put a PID control, a proportional control, whatever that could make sure that the robot will reach the speed. Okay, now we don't have time for this, so what I'm gonna do is to compensate the PWM that I apply for the front wheels and the back wheel. Because I don't know if you realized, but when my robot tried to go sideways, it doesn't go perfectly side. It rotates the back more, and then make my robot rotate like this. So what I'm gonna do is to apply more power to the front wheels and less power to the back wheels. And then this way we are gonna kind of compensate this issue. So my robot's going left. I'm gonna deploy again. So now I have less power on the back and more power on the front wheels. So even with this weight issue, it's gonna move a little bit better. I hope so. Let's see. Okay, it's more far here. Okay, it's not going probably disconnected. Let's connect to the robot. Things like that. Let's connect to the robot. Connect. There's a bug with the FRC software. Okay, so left 15. Let's try it. So if you see, it didn't drift, it didn't rotate that way like before. So it moves a bit better sideways. You can see the camera can realize. To rotate less in place and go more sideways. That way, because I'm compensating the power, the front and on the back. This robot is having an issue. I think the problem with this VMX last week, the robot from last week didn't have so many issues. But anyways, right side works, left side works, front works. Here, because I don't have PID in this code, I just compensated through the power to balance with the weight of the robot. Okay, and then now you can use for going right, going left, going front. To follow the line, I put the copper sensor here. So here I have the cobra sensor below, and here I put the tape. So the idea is to make my robot move sideways until it reaches the tape. Once the two sensors in the middle of the cobra reaches the tape, it stops. Okay, so the cobra has, let me find cobra here. Cobra has 4 photosensors. These guys here, they work similar to the sharp sensors. They are AR sensors. Okay, they send the beam of infrared light to the floor. If the floor, according to the color of the floor, the power that comes back to the sensor is different. So when it's measuring white, it's going to have a measurement. When it has black, when it sends the beam to a black surface, the light that comes back is different. And this way, the voltage will also be different. That's how we can determine if we are reading a black or a white surface. For this code, we're going to do similar to the sensor drive code. So here below, I'm going to create a new code. So there's no return. It's under rudiment class. The name I'm going to put a line. Okay. There is no input. I don't need to inform. Actually, there's the possibility of going right and left. So I'm going to add also a direction input. Direction. Okay, this guy, it has to read the cobra. To read the cobra, I come here to hardware. Hardware have the function get cobra. That's the function we're gonna use. Get cobra has one input, which is the channel. What's channel? Channel is gonna be one of these 4 sensors here. So I can measure individually each one of them. So I'm gonna put 0, 1, 2, 3. Okay, so here in the code, I'm gonna do the reading. So I'm gonna have Cobra, say left sensor, start as was, and then I'm gonna have 4 of this guy. Left, I'm gonna have right, I'm gonna have center left, center right. Okay, these are all the sensors we have. I'm going to loop this process because I want to keep repeating the movement until I reach where I want. So what's the condition for stopping? I will repeat this process while the Cobra sensor left or Cobra sensor right didn't reach the tape. So until I have a situation where one of them is not in the black tape, I keep repeating this process. It means that while I'm in the white, I'm repeating. When I reach the black tape, okay, when the sensor, the two sensors in the middle of the Cobra are on top of the tape, then I stop. Here, just like we did before here, I'm gonna start updating the sensors. So I'm gonna copy these guys. And then different from last time, now I have 4 sensors update, not only one. And then to update them, I need to take from the hardware, the function that we just saw, get Cobra. Okay. Which number should I put here? That's what we're going to have to test later, actually. Because I don't know now if 0 is left, if 0 is right, if, you know. So what am I going to do? I'm going to put a number by now. Later we might change. Then I'm going to print. So just like I did here, I'm going to print on the shuffleboard. Left, right, all of them. And then this way I can know better. Instead of left, I'm going to do Cobra 0, Cobra 1, Cobra 2, Cobra 3. And this way I know. I can test and see who is who. So 0, 0, 1, 2, 3. And then later we can test. Okay, I'm going to do, I can either go left, STD, string direction. So I can either go left or right. So I'm going to have a condition similar to what we did here. So if right, do something. If left, do something else. So if my user want to go right, I'm going to move like we move here. So I'm going to put it here. If it's left, go to the left, it's this guy here. Okay, so if I want to go to the left, okay, else if case I want to go to the, sorry, before was right, so now it's left here. So if I want to go to the left, I'm going to go to the opposite direction. Okay, else. So if my user asks anything that's not right or left, I break. So I'm not going to do anything. I'm not going to move at all. Okay, and then the part of movement is the same as this guy. Why? Because inverse kinematics calculate what's the combination of power I need in each wheel in order to perform this movement, to move in Y, for example. And then I apply to the motors here, left, right, and back. Okay, just like the other code, I'm going to make sure here in the end that I stop the wheels. Okay, because I created a new function, I need to add to the class. So I come here. Okay, so now my class has this method here, line and line. Okay, so I start checking the Cobra. I'm gonna build to make sure I don't have any syntax error. Okay, no error. And I'm gonna call this function here. So instead of sensor drive, I'm gonna call line out. I don't have a distance. I won't have a direction. In this case, right? So I'm gonna deploy. Now I don't want it to move. I just want to check the shuffleboard if who is left, who is right, who is sensor left, who is center left, who is center right. So I'm gonna run here. See, it's not connected to connect. Just 1 minute. Just there's someone calling. Okay, so now connected. Let me deploy. Okay, let's see the shuffleboard now. We have the sensor reading. What they get? Okay. See. Still up to date deploy again. This VMX, it's having some connection issues. Maybe the battery is low. Let's try. Set position, right now live. Let me see. And select. I think it reads here. So sorry, what we're gonna do. Just test. I'm gonna put it through here. So this loop will run forever, even if these guys match with the condition here. I don't want to stop the loop. I want to keep it forever because I want to read the numbers. Let me deploy. So Cobra, if we take a look at the sensors and the numbers here, you can see. So on the white, it's reading 3.2, 3.5, 3 point something. When I go to the black tape, they go to 5, all of them. See, so on the black, they're closer to 5. On the white, they're less than 5. Here, my sensor is too low. is too close to the floor. That's why. So here, the white, the black. See, there is only one sensor heating. So you see that according to which sensor is on the black, it changes the numbers. So 5 would be those that are far. Okay, so here now everybody's white. Then I'm passing through the black. So the black is 5. The white would be something close to 0. In my case, in your case, it's going to change a little bit. Okay, so when I go to the right one first, you see that Cobra 3 goes to 5. So Cobra 3 is the right sensor. And then Cobra 2 is the center right, and then go on. Okay, so now I can come here, remove this true that I put before. It means that I want to stop the code, not keep running forever. And now I know that 3 is the right. I know that the center right is going to be 2. I know the center left is going to be 1. And I know that left is going to be 0. Okay. So now my code, what will happen? I'm checking these guys. When sensor left and sensor right are true, they're going to stop the while loop. The condition for being true or false is, we saw that 0 is when it's white and 5 is when it's black. So I'm going to put, if what I'm reading is greater than 2.5, it means that I'm on the black. I'm going to do here for all of them. Okay, so I'm checking. I check the sensor. If the sensor is greater than 2.5, it means that I'm on the black. If I'm less than 2.5, I'm on the white. Okay, and then I'll be checking. If I put right, it goes to the right side. If I put left, it goes to the left side. Use the opposite, right? So the negative is the right, positive is the left. So here, put left. So I'm going to run. This guy here. So left, positive, right. See. I have an issue because my Cobra is not fixed well. I'm gonna hold the Cobra and the robot can. Okay, so it goes to the left. When both sensors hit the tape, it stops. In my case here, the sensor is not well fixed, so it's oscillating a lot. Try to fix it. Try to run again. So the robot moves to the left until it sees the tape. Where's the Cobra? My Cobra is too far from the wall. The Cobra to be used well, it has to be very, very close to the floor. In my case here, it's not as far, so it oscillates a lot. But if you see, it moves to the left. When it hits the tape, it stops. Let's try the right side of it. I have to hold also. Okay, I put here right. I deploy. I'm just holding the sensor to make it lower. I need to go to the right side when it sees the tape. I don't know if the camera in another position. Here, press the robot far from the tape and deploy the code. And then I'm going to put my finger just to make the cobra more close to the floor. So my robot moves. When it sees the tape, when the two middle sensors of the cobra see the tape, my robot stops. Okay. And that's the sensor drive function and the line align function. The line align for aligning with the tape, and the sensor drive for driving to the direction you want. It's late now. Those that want to leave the meeting, no issue. Okay, because I know that's late. But I'll just give a brief explanation about the setting the robot position. Okay, so now I have the line align to stop in front of the tape. I have this guy for following the wall, getting close to the wall. And then I mentioned about resetting the robot position. To reset the robot position, I mean that when my robot's moving, let's take the image of the bird here. Okay. So my robot's gonna perform the same task many times. So starting from the initial point, go, take one cube, deliver the cube, come back, go, many times. Every movement my robot does, it gets an error. So, and this error will be accumulating. Once a while would be good for me and for my robot to reset this error, to make this error 0. To do that, we're gonna reset the robot position. So if my robot gets here with an error, so let's say I send my robot to the position 20, but actually my robot's in the position 30. So I need to tell my robot that the position is 30. And to do that, we have, it's not an equation, but it's more logic. So for example, if my robot is stopped here, that's my robot. Here is the front of my robot. Okay, I have one sensor here, I have one sensor here, I also have another sensor here, I also have another sensor. My robot has 4 sensors. And then I need to say to my robot, what's the robot X and Y regarding the center of the robot always. To do that, what can I do? I measure the distance from the sensor to the wall. Okay, here in this case, I'm going to call sensor right. Here's wrong. To be sensor left, right? It's sensor left of my robot. Okay, but there is one distance missing to the center of my robot. This distance I'm going to call offset because it's fixed. This guy never changes. So for example, let's say this guy is 10. So what's my robot X? My robot X is whatever I measure using the sensor left plus 10. So if I measure 10 here, the X of my robot is 20. Okay? The same for Y. But in this case, it would be a little bit more complicated because I would have to do 200 minus the sensor minus the offset. Okay, so that's what I mean. So in the beginning here, let's say, first of all, I'm going to have to define a reference point. My reference point, for example, would be this corner. So I have a X, I have a Y, and my robot starting. Let's say my robot start facing down. My robot start facing down, it means that my robot's angle is 270. Okay? Let's say that my robot's right in the middle of this square here. So my robot position would be 30 in X, 30 in Y, angle 270. Okay? And then my robot moves. My robot, so here my code would be, first of all, I set my robot position to 30, 30 to 70. And then I want to move close to the dispensary here, close to the shelves. So I need to do my position driver. I can do move to here, move to here, move to here, and let's say I go to this corner to use the sensors. So here is in the middle of the court, so is 100 in X. So it will be position driver. Just an example. It will be 100 in X. I keep the same Y. I keep the same angle. I do it to rotate. Then I go to go up. I keep the same X and I change Y. So 100. Let's say 100. Then I want to go to this third point here. This third point will be, let's say, in the middle. So it's going to be 50. 50. Oh, and then here I want to rotate. So I keep the same X and Y and rotate to 90. Okay, so now my robot's here facing the shelf. And to be sure that my robot will be accurate when it goes to PQ, I want to use the sensors. So I send my robot to this position here. My robot will stop here. Okay, so more close to the wall would be 5, 7. So my robot's here, very close to the walls. But I send my robot to 25, 170. But doesn't mean that my robot will stop exactly 25, 170. Because while moving, my robot got errors, many errors. So my robot thinks that's in 25, 170. But actually my robot is in 30, let's say 160. To my next move that be accurate, I need to make sure that my robot knows this error. And to know this error comes the resetting the position. So I need to redefine my robot position, telling my robot the real position. So what I'm going to do? I'm going to calculate my robot position. So I have a robot X, and I have a robot Y. The angle will be 90. Actually, would be the current angle of my robot. How much the X of my robot? The X of my robot will be this one here. Will be my sensor left. Left. Sensor left. So whatever my sensor measured here, plus the distance from the sensor to the middle of my robot, right? Because my sensor measures from the wall to the sensor itself. But the X and Y of my robot, I always measure regarding the center of my robot. So I need to add this distance from the sensor to the center. Let's say that. So what I'm going to do in my code, I'm going to do the sensor, which is hard dot get left distance, so before, plus 1. That's the X of my robot. When I do this, my robot will know that the X is not 25. My X actually is 30. And the same I do for Y. But Y, the count distance. But the Y, if I analyze here, my Y is the sensor that I read here, plus the offset, that's from the center of our robot to the center. But this doesn't give me Y, because Y would be this distance here, the distance from my reference point, which is in the beginning, to the center of my robot. That's Y of my robot. That's the Y I want. So how can using the sensor that give me this distance here, I can find this one. To do that, I would have to know the port measurement. What I know, which is 200. So my robot Y, in this case here, is Y equal to 200 minus front sensor minus the offset. Let's say in this case. So that's my robot Y. So here in my code, I would do front distance, so 200 minus front distance plus 15. Or if you want to remove the parentheses, you can do minus sensor minus 15. This here will tell my robot that my robot is actually in 160 and not in 170. Okay. I take this robot X here, I take this robot Y here. My angle is the current angle, so I'm gonna do move dot get H that returns the current angle. Why I wanna do all of this? Because of this error. If my robot has a 5 centimeters error here, it means that the next movement I do, my robot will have 5 centimeters error. So if I send my robot to go in front of this cube here, for example, my robot will not stop in front of this cube. My robot will stop 5 centimeters away from the position of this cube. So the idea of resetting the robot position is eliminating these errors in order to make the next movement. So for example, when my robot comes to here in front of the cubes, his next movement will be accurate because here I eliminated the error. There's no error. Of course, moving from here to here, I'm going to get a little bit error, but it will not be 5 centimeters. It will be 0.5 centimeters. It will be 3 millimeters, you know? So that's the idea of resetting the robot position. This way, I can use the position driver for the whole task. So later, after taking the cube, I send to this position again. I send to this guy here. For example, I send to the side here. I use the line align function. I put the cube, then I come back to this point, then I go back to this corner. I use the sensors again. I reset the position. I go in front of the next cube, and all these movements will be okay. The line align function I can use for taking the cubes and placing the cubes. I have 4 lines, and then it's up to you which strategy you're going to use. If you want to align with this guy, for example, let's say I want to take this second cube. You can use line align to the first line, and then you can call it again. Or you can send position driver, the robot here. You can send the robot to the middle between them, and then do line align 1 time to this line here. Okay, it's up to you. If you decide to do line align 2 times, go to this guy, and then call line align again. So would it be something like, for example, like this? You need to take care that line align stops when the 2 sensors in the middle are over the line. So the problem calling the line align twice is I called the line align 1 time, I'm over the line. If I call the line align again, I'm already on the line, so my robot will not move. My robot will think that I already reached the line. So if I want to use line align 2 times, I have to call line align, move a little bit my robot with position driver or something else, and then call line align again. Or if you want, you can try to change the logic here to make you able to call it twice. Okay, that's from my side. I know that today was a lot of informations. I will send this code. Please review. Okay, all of these codes, they work well. Fortunately, the robot I picked for this training, it has some connection issues, so you see that it's connected many times, but it's not supposed to happen with your robot. Okay, I can use sensor drive for getting close to the walls. I can use line align for making my robot be accurately in the middle of the tape. Okay, and I can use the sensors for telling my robot the real position in X and Y. Okay, and then I can combine with position drive. So here I could use set position, position driver, position driver, position driver. Here to make sure I'm close enough to the wall, I can do sensor drive left, sensor drive front. I do robot X, robot Y, set my robot position. Now I'm pretty sure that my robot is where my robot thinks it is, without errors. And then here I can either send position driver directly without needing of the data because I set the position here, my next movement will be accurate. So maybe you don't even need to follow the data, to align with the data. Because you set it, you correct the error, the next movement you do from here to here will be accurate. Okay? But if you want to use the line align, it's up to you. And that's it. Any questions? Probably some. No questions? Okay. In case you have during the week, please send the WhatsApp group. Whenever I have some time, I'm gonna answer. I'm gonna send all these documents and the code for you. Then you can try, you can test, study it, change it according to your needs. Okay? So thank you very much.